This is version 1 of our board, and you saw in my last video that when I tested it that it was working, but during our first test, which was not on the video, when we first tested it, we encountered some ghosting. Ghosting is when two or more switches are turned on at the same time. So I wasn't experiencing that problem before because most of the control boxes I make are using momentary switches. It's like tactile buttons. So none of the switches gets left on. But on the miscellaneous panel, practically almost all of them are toggle switches, which means that it stays on at some point and is left on. Like for instance, this is an on-on switch, so it's always on. And that causes ghostings. Like during our last test, when I leave these two switches on for the autopilot to be active, if I were to do a master arm, instead of doing a master arm, it turns off the radar, something like that. And in other words, it messes up the controls when some of the switches are left on. And then I realized, okay, that's ghosting. That's exactly what ghosting is. So, and the way to solve that is to like add some diodes on your circuit. Let me try to show you. So the way this whole thing works, it's what's called a button matrix. So we have several buttons, right? So buttons would be like your switches. That's a switch. Here's another switch. There's another switch. So since it's a matrix, you'll have rows and columns of switches. So let's say we have nine switches, which is organized in rows and columns. So that's column 1, and this is column 2, this is column 3. Then we'll have the rows. You have row 1, row 2, and row 3. Okay. So when you implement this on a microcontroller like in the Arduino, instead of using 9 individual pins, you'd only need 6, because it's a matrix. So in order to implement that, what happens is you have these rows and you have your columns connected to your pins. So let's say this goes to pin 7, pin 8, pin 9, while this goes to your pin 10, pin, let's just say 11, and pin 12. So Connect this to the columns. And connect this to the rows. So this is basically how the button matrix is organized without diodes for now. Okay, so using momentary switches, there's no problem because only one switch will stay on at any given time. So what happens here, how it works basically is your program goes through R1, R2, R3, sending signals through each of those at one time. So one at a time. So and then it waits. It waits on at this point. Columns C1, C2. C3, it waits for the signal there to determine which switch is on basically. So if this is on, signal goes there, so you know that R1 C1 switch is on, and if this is on, signal goes there, so you know that R1 C2 is this time is on. Okay. Now, ghosting happens when you are using toggle switches, which leaves the switch on. So for instance, switch 1 is on. And let's say C2 is also on. That's still not a problem because on first pass, signal goes here, so C1 is on, so R1 C1, this switch is on, signal continues, goes through, so R1 C1 and R1 C2 are both on, no problem, right? So let's leave those two switches on. Next pass, R2, R3, none of the switches are on. Now, let's say those two are still on, and we switch on, we turn on R2 C1. Okay, so on the first pass, it's still normal. R1 C1 will be on. R1 C2 still on, good, no problem. Now R2 C1, yeah, still goes through, no problem, it's still right, it's still correct, still get it here. But when that happens, you know, remember you're sending an R2 signal. So R2 C1 is on, okay? R2 C2 is supposed to be off, right? Right, so, but what happens with your R2 signal is that it travels back up here because this is connected. See? Goes up here. And what happens is this whole line is also energized with your R2 signal. Are you getting it? And because it's now R2, it sees that this switch is on, goes down there, and receives an R2 C2 signal, which is wrong because this is off. It's not supposed to receive an R2 C2 signal. You're getting that? So that's the problem with ghosting. It messes up the signals. all the more when you have more switches turned on. So the solution here is actually simple, and it has always been documented. The way to go is just to add diodes on your rows. So let's say add a diode here. Now, what does this do? It's basically, the diodes basically prevents the signal from going back. It's sort of like a one-way line. So with the diodes, here's how it will go. Given the same scenario, you have C1 and C2 both turned on, for example. Given the same scenario, it will still work same way. Now, what happens now when you switch on R2 C1, R1 C1 should stay on. Yes, goes there. Yeah. R1 C2 on, no problem. R2 C1, of course. Yep, that'll still work. Now what happens? This R2 signal goes up here, switches on, but it meets the diode there. Doesn't let the R2 signal go through the diode, so your R1 line is still clear. So no other signals, not C2, will be read. So R2 C1 will be the only button active during the R2 signal. And that's how the diodes help. And this is how we implemented that on our board. We added this diode 7 actually. So that's the mod we did, which is very important. So I practically wasted like 5 boards without diodes, but although on my first test I managed to like solder the diodes directly just to test if that is indeed my problem. So, but that was obviously the problem. So I had to Dremel the foils and added diodes. Like, these are not even surface mounted diodes, so I had to like physically solder it like that, and it worked. You saw on my testing that was still version 1, but with the diode soldered in, and that worked. So having seen that it worked, I modified the design, and there we have it. We sent it off for fabrication. So works now.